Hi there, this is Professor Eckhouse, and I am going to talk today about polynomial functions. So you're going to define and identify polynomial functions, and you'll learn how to identify some general characteristics and recognize polynomials from their graph, and then do some algebraic operations. All right, so polynomial functions of degree 2 or more, that means x squared or more, like x cubed, x to the fourth, is the highest power of that polynomial. So remember from last time, that's what a degree means. There's two things that they cannot have. And if they don't have these things, then they are a polynomial. So they do not have sharp corners. In other words, they are smooth curves. And they have no breaks. In other words, they are continuous. So the word is continuous. So you can think of what they don't have or what they do have. So by smooth curves, we'll call this one number 1. So number 1, smooth curves, it always does this. It never does, like that. So that is a sharp corner right there. We don't want any sharp corners. So this is not considered a polynomial. That's an absolute value function, not a polynomial. Okay, so anything with a sharp corner is not a polynomial. And there's a reason why. There's some things that happen to the function that cause it to have that sharp corner. So the second reason is that it has to be continuous. Okay, so if it's smooth and continuous, it is a polynomial if it has a degree of 2 or more. So having no breaks means, like we were looking at functions that were piecewise functions and it kind of went like that, right? So that is a break, right? So it can't have any breaks like that. It must be continuous. Okay, so like that right there. Has to be continuous. So that is a polynomial function. So if it's smooth curves and continuous all the way through and doesn't have any breaks anywhere, so something like this, and then it stops and it goes on like that, that is not a polynomial function. Okay, so going on. Which of the graphs below represent a polynomial function? So let's look at all 4 of them. So pause the video and think about which ones are polynomials. Okay, so hopefully you see that this one is a polynomial. It's smooth and continuous. This one is not a polynomial. It is not smooth. It has a sharp corner right there. The bottom left one is smooth and continuous, so it is a polynomial. And the last one, the bottom right, is not continuous. It has a break right here. So it is not a polynomial. Okay, continuing on. What is the domain of a polynomial function? So look at those 2 polynomials there on the left. What is their domain? In other words, what are all of the possible values of x? So remember, these have arrows on the end and they go on forever, which means the x value is going to keep going left and right forever on both of them. So the domain is all real numbers, which we say as negative infinity to infinity. Okay, so that is the domain. All right, so the shape of a polynomial function. If it has an even degree, 2, 4, 6, 8, and by that I mean it can have other things. So like this x squared could be plus x minus 1 or something like that, and it will still generally have this shape. So as long as the highest power, the degree of the polynomial, and that's what we said right here, the even degreed polynomial, is even, 2, 4, 6, 8, 10, and so on, it will look in general like that. In other words, the ends do, and this is how I describe it, do that. The ends go up and up. All right, what if it's an odd degree though? An odd degree. Look at what happens with an odd degree. So the teal one is the cubed, the orange one is the 5th, the dark blue one is the 7th. You can see their shapes are very similar, and their ends are doing this. Okay, so the top is going up to the right. Sorry, the right side is going up, and the left side is going down. Okay, so odd degrees go in opposite directions. All right, now what if the sign, the original number, had a negative in front of it? So like what if this right here was a negative x cubed? What would happen? Well, it's going to flip over the x-axis. It reflects. Now think back to transformations, and it's going to reflect and flip over the other way. So let's talk about what these are all going to look like. So a negative leading term is going to flip it over. But let's just look at the positive one first and what we just did. So the sign of the leading term is positive. An even degree polynomial in general is going to look like that-ish. Like this part right here might look a little different. It might be a little flatter. As you can see, they got flatter as the exponent got bigger. But in general, it looks like that. An odd degree polynomial in general looks like that. And of course, it flattens out a little bit as the exponent gets bigger, but in general, it looks like that. So now let's think about if the leading term, the first term, is negative. So what happens, just like in transformations, is it's going to flip over. It's going to flip over and it's going to face like that. So if it is negative and an even degree, it's going to flip over and face downward. What if it is negative and an odd degree? How is this going to flip over? So I want you to try to picture that. And that is going to test my drawing skills. Do something like that. Okay. So, got a little buzzing, so I'm going to turn off some lights here, see if I can get it to go away. All right, so that is even degree, odd degree, positive, and negative. In general, what they look like. All right, so let's take a look at these. Identify whether the leading term is positive or negative and whether the degree is even or odd. So pause the video, go back to your notes that we just took right here, and see if you can decide if the leading term is negative and if the degree is odd or even. All right, so I'm going to say that the leading term, it's LT, is going to be negative because it's facing downward, right? So it is negative. So the first term has a negative in front of it, the leading term, the one with the highest degree. And the degree of this thing is even or odd. What do you think? They're both going in the same direction. So let's go up here and look. It's negative. It looks like this one in general, so that means it is an even degree polynomial. Okay, so I'm going to erase some of this because we're going to come back and use it again. All right, so the degree is even. All right, let's look at the next one. You might want to pause the video and try this one. All right, so the leading term is going to be what, and the degree is what? All right, let's talk about the degree first. The degree is going to be the one that goes in the opposite directions. It's going to be odd. It's going to be odd because it's going in opposite directions. One's going up and one's going down. But if it is positive, it goes up to the right and down to the left. This one is negative. It goes up to the left and down to the right. So it does, that was really bad. It goes like this, right? So this one is, the leading term is going to be negative. It's been flipped over the x-axis. This is negative and an odd degree. Okay, so moving on, performing algebraic operations on polynomial functions. So this is a new way, new notation. We've already done most of this, not the division, but we've done everything else. Adding polynomials, subtracting polynomials, and multiplying polynomials. We're not going to do the division, but I'm going to show you how to evaluate with division. So addition is this first one, f plus g of x equals fg plus f of x plus g of x. F minus g of x is f of x minus g of x. That's a shorthand for it, okay? Just two different ways to say it. And the same with multiplication and division. Okay, so let's practice this. So let f of x equal this first one and h of x equal the second one. And what we're supposed to find is f plus h of x. So pause the video and go up and look and see if you can rewrite f plus h of x. The way you're going to rewrite it is f of x plus h of x. Well, f of x is this one, and h of x is this one. So we need to put both of those with an addition sign in between. So we're just adding them together. We've done this already in the last lecture. So this is just going to be 3x cubed plus 5x squared minus 2x minus 1. We could use parentheses around them if we want to, but since it's plus, it's not that big of a deal. X minus 3. It's not going to change anything. Okay, so now we're just going to find the like terms and combine them. So I've got an x term here, so I'm going to go find my other x term here. I've got a constant term here and another constant term here. The other two don't have anything to combine with, so I'm just going to rewrite them. 3x cubed plus 5x squared. Now I've got minus 2x plus x is going to be minus x. And then I've got minus 1 minus 3, and I get minus 4. And it's in order, decreasing degree, so this is in standard form because I go from 3 to 2 to 1 to nothing. All right, so that's the final answer on that. Now the next one is asking us for h minus f of x. So pause the video and see if you can rewrite that separately. Okay, so hopefully you got h of x minus f of x. All right, so h of x is going to be, and I'm going to bring this a little closer so I can still see everything. All right, so h of x is going to be the green one. That's the second one, so be careful that you do the right one. So the first one is the h of x, that's x minus 3. And be careful because we do have subtraction here, so I am going to use parentheses for sure. So we've got 3x cubed plus 5x squared minus 2x minus 1. The first thing you should probably do is take care of the parentheses. So now I'm going to distribute the subtraction right here. So subtract 3x cubed, subtract 5x squared, subtract negative 2x, which means to add 2x, and subtract negative 1, which means to add 1. And now I'm going to combine like terms. So I've got my x term right here, and I've got my constant term right here. And the others don't have anything to combine with, but I'm going to rewrite this in descending order. So negative 3x cubed minus 5x squared. Now I'm going to do the orange ones, which is the x term. X plus 2x is 3x. Minus 3 plus 1 is minus 2. That's the final answer in descending order, so it's in standard form. All right. So since f plus g of x equals f of x plus g of x, how would you write f plus g of 2? Well, that is just going to be f of 2 plus g of 2. All right, so we're going to use that in the next problem here. So there's two different ways to evaluate things when you're asked to evaluate. If I'm being asked to evaluate f plus h of 2, I can either evaluate each first and then add, or I can add and then evaluate. All right, so we're going to do that now. Let's evaluate each first and then add. All right, so remember f plus h of 2, parentheses in the wrong place, f plus h of 2 means f of 2 plus h of 2. So I'm going to find f of 2. Okay, so that's going to be the yellow one. So f of 2. All right, so 3 times 2 cubed minus 4 times 2 plus 2. So I encourage you to pause the video and try these. All right, so I get 3 times 8 minus 4 times 2 is 8 plus 2. So this one is, I think I just lost myself. This one is 18. So 24 minus 8 is 16 plus 2 is 18. All right, then the next one is going to be h of 2. And we'll do this as this is going to be the green one right here. Okay. So h of 2 is just plug 2 in for x plus 2. And that's going to equal 4. Okay, so now f of 2 plus h of 2 equals f of 2. Let me use my colors. F of 2 is 18 and h of 2 is 4. All right, so I get f of 2 is 18 plus h of 2 is 4. All right, so here is my f of 2, and here is my h of 2. And I get 22. All right, so let's try it the other way. We're going to add the two equations, f, I keep rewriting and writing that wrong, f plus h of x is going to come first. We're going to do it without the 2. So f of x plus h of x. And that is going to be 3x cubed minus 4x plus 2 plus x plus 2. All right, so I get 3x cubed minus 3x plus 4. All right, now I'm going to find f plus h, that's what I just found, f plus h of 2. All right, so I'm going to say 3 times 2 cubed minus 3 times 2 plus 4. All right, and I get 3 times 8 minus 6 plus 4, which gives me 22. And if you look, we got the same answer both times. So you can pick the way that you prefer. You can add, subtract, whatever the functions first and then evaluate, or you can evaluate the two functions separately and then do the addition, subtraction, multiplication, or division. For division, you're going to have to evaluate first and then divide, because I have not taught you how to divide polynomials in this class. All right, so this one we're going to multiply. So we're going to find g times f of t. So g times f of t is going to be g of t times f of t. In other words, we're just going to multiply these two equations. So I get 2t squared plus 5t, that's g. Okay, so that is my g right there. Times f of t, which is 3t squared minus 1. That is my f, and my f right there. Following that through. All right, so now we're just going to FOIL it. So we're going to multiply the first two, 2t squared times 3t squared. And then I'm going to take the 2t squared times negative 1. And then I'll take and I'm just distributing 5t times 3t squared. And then plus 5t times negative 1. All right, so I might want to pause the video at this point if you haven't already and try to work this out. And you should give it 6t to the 4th minus 2t squared plus 15t squared cubed minus 5t. All right, so I'm going to put this in order, and I get 6t to the 4th plus 15t cubed minus 2t squared minus 5t. Okay, double checking all the details. All right, so next we're supposed to evaluate that same thing, g of f of negative 1, and that means we're just going to plug negative 1 in. So we're going to take g of f of x, which is what we just, or t, g of f of t is this right here, right? That's what that one is, 6t to the 4th and so on. So I'm going to say g of f of negative 1, and I'll just plug negative 1 everywhere I see t. So 6 times negative 1 to the 4th plus 15 times negative 1 to the 3rd minus 2 times negative 1 squared minus 5 times negative 1. Please, if you have not already, pause the video and practice doing this kind of evaluation. So I get 6 times 1 plus 15 times negative 1 minus 2 times 1 plus 5. Negative 5 times negative 1. And that gives me 6 minus 15 minus 2 plus 5. And that gives me negative 6. Okay, so evaluating g times f of negative 1, in other words, multiplying the two equations together with negative 1 plugged in, gives me negative 6. Okay, what if the problem only asked you to evaluate? Would this be the fastest way? So which one is the fastest way if it only asked you to evaluate? So what I would probably do if it asked me to evaluate is to evaluate each one separately and then do the math. And I'll show you what I mean by that, because this time we're given division. So we're supposed to find p over r of 2, which is the same thing as p of 2 over r of 2. So let's find p of 2. P of 2 is going to be 2 times 2 squared plus 3 times 2 minus 8. And I'm using p right now. That's p of 2. All right, and that is going to give me 6. R of 2 is going to be the other one. So R of 2 is going to be 2 minus 3, which is -1. So now we're going to use this one and this one for P and R, and we're going to plug them in, and we're going to get, I forgot to highlight my R. We're going to plug those in, and we're going to get 6 over -1. So P of 2 is 6, R of 2 is -1, and we get -6. So the answer to this P over R of 2, and this really should have that around it, is -6. Okay, that's all I've got. Thank you for watching.